In this homework, we are going to perform deep exploratory data analysis, EDA, and feature engineering on the AirQuality dataset. The goal is not only to run code, but to understand how to inspect a dataset, how to clean real-world data, how to extract information from data, how to prepare data for machine learning. This notebook follows the exact structure of the homework, so every step corresponds to a part of the assignment. Before working with data, we need tools, libraries. Libraries are collections of ready-made functions that help us analyze data. Think of them like toolboxes will help us to do the task. We start with pandas. Pandas is used for data manipulation and analysis. It allows us to work with tables of data, similar to Excel. Pandas calls this structure a data frame. We shorten the name to PD so we can write shorter commands. NumPy is used for numerical computations. It helps with mathematical operations, large arrays, scientific calculations. Example: mean, nup.std for nup, standard deviation. We use np as a shortcut. Matplotlib is used to create graphs and visualizations. Examples: line plots, histograms, scatter plots. Example: plt.plot, plt.heist. We use plt as a shortcut. Import Seaborn as SNS. Seaborn is a visualization library built on top of Matplotlib. It helps create more beautiful and informative plots. Examples: correlation heat maps, boxplots, statistical graphs. We use SNS as a shortcut. palti.style.use, Seaborn, v008. Explanation. This line changes the appearance of all graphs. Without this line, plots look very basic. With it, plots become cleaner, easier to read, more professional. Think of it as applying a visual theme to all plots. Here we load the dataset into Python. Read.csv means read a CSV file, but the AirQuality dataset does not use commas to separate values. Instead it uses, so we tell Python, sep. This means use semicolon as the column separator. What is DF? DF stands for data frame. A data frame is a table structure like Excel. So if you have a table for columns and rows, we store the dataset in DF. Next, df.head. This is calling the data frame header, which shows the first 5 rows of the dataset. This helps us quickly understand what columns exist, how the data looks, if there are errors. The first line of code is print, followed by the text column names. In this line, we are simply printing a message to the screen. The purpose of this message is to clearly label the output that will appear next. When someone reads the results, they immediately understand that the next information shown will be the list of column names in the dataset. The next line of code is df.columns. Here we are asking the dataset to show all the column names it contains. The variable df represents our dataset, which is stored in what is called a data frame. A data frame can be imagined as a table similar to an Excel sheet. The word columns refers to the vertical categories of information in that table. By calling df columns, we obtain the names of every variable in the dataset. This allows us to see what types of measurements are available, such as pollution levels, temperature values, humidity measurements, and sensor readings. The next line of code prints the text dataset shape. Again, this line does not perform any analysis. It simply prints a descriptive label that organizes the output. When someone looks at the results, they immediately know that the next information will describe the size of the dataset. The next line of code is df.shape. This command tells Python to display the size of the dataset. The shape contains 2 numbers. The first number represents the number of rows, which corresponds to the number of observations or measurements collected. The second number represents the number of columns, which corresponds to the number of variables recorded in the dataset. In other words, the shape tells us how large the dataset is and how much information it contains. The next line of code prints the text data types. This line again serves as a label to clearly indicate what kind of information will be printed next. It helps organize the output and makes it easier to interpret. The next line of code is df.dtypes. This command displays the data type of each column. A data type describes what kind of information a column contains. Some columns contain numerical values, which can be used in calculations. Other columns contain text values, such as date or time information. Understanding the data type is important because statistical analysis and machine learning models require numerical inputs. If a column that should contain numbers is stored as text, We will need to convert it during the data cleaning process. The next line prints the text first 3 rows. This line again creates a label that tells the reader that the next output will display a small sample from the beginning of the dataset. The next line of code is df.head, with the number 3 inside the parentheses. This command displays the first 3 rows of the dataset. It allows us to quickly inspect how the data looks. By looking at the first rows, we can check whether the dataset has been loaded correctly and whether the values appear in the correct columns. The next line prints the text last 3 rows. This label indicates that the next output will show a sample of the dataset from the end rather than the beginning. The final line of code is df.tail, with the number 3 inside the parentheses. This command displays the last 3 rows of the dataset. Looking at the final rows helps us verify that the dataset ends correctly and that there are no incomplete or corrupted entries at the end of the file. Together, these commands allow us to perform the first essential step in data analysis, which is understanding the structure of the dataset before performing any further processing or modeling. In this step, we are checking whether the dataset contains missing values. In real-world datasets, it is very common that some measurements are missing. Sensors may fail, measurements may not be recorded, or data may be corrupted. Because of this, many datasets use special values to represent missing data. The first lines starting with the hashtag symbol are comments. Comments are not executed by the computer. They are written only for humans to read. In this case, the comments explain that we are in step 3 of the analysis and that the dataset uses the number -200 as an indicator of missing values. The next line of code prints a message to the screen that says, "Missing value indicators -200." This line simply creates a clear label in the output so that anyone reading the results immediately understands that the next numbers correspond to missing value counts. The following line contains the main operation. The command compares every value in the dataset with the number -200. In this dataset, -200 was used to represent missing sensor readings instead of leaving the cell empty. Therefore, the program checks every position in the dataset and asks a simple question. Is this value equal to -200? This comparison produces a logical result for every entry in the dataset. If the value is -200, the result becomes true. If the value is something else, the result becomes false. After that, we apply the sum operation. The sum operation counts how many true results exist in each column. Because true values are treated like ones in counting operations, the program adds them together and gives us the total number of missing values for each variable. The result displayed on the screen shows each column name followed by a number. That number tells us how many missing values exist in that column. For example, the column that measures non-methane hydrocarbons contains a very large number of missing values. This tells us that many measurements were not recorded for that variable. Some other variables, such as temperature, relative humidity, and absolute humidity, show 0 missing values, which means the data for those variables is complete. This step is extremely important in data analysis because missing values can affect statistical calculations and machine learning models. Before we proceed with further analysis, we must identify where missing data exists and decide how we will handle it during the data cleaning stage. Step 4. Check duplicate rows. Check the first line of code print, duplicate rows, df, duplicated, sum, explanation for presentation. In this step, we check whether the dataset contains duplicated rows. The command begins with the word print. This simply displays the result on the screen so we can read it. Inside the print statement, we write the text, duplicate rows. This is only a label that helps us understand what the number represents when it appears in the output. After the label, we use the dataset stored in the variable df. The method duplicated checks every row in the dataset and compares it with all other rows. If 2 rows contain exactly the same values in every column, the method identifies them as duplicates. The duplicated method produces a series of logical results. For each row, it returns true if the row is a duplicate and false if it is unique. Next, we apply the sum operation. Since true values behave like the number 1 and false values behave like 0, the sum operation counts how many duplicated rows exist. The final number displayed tells us how many rows in the dataset are repeated. Duplicate rows are important to detect because they can distort statistical analysis and machine learning models. If the same observation appears many times, it can bias the results. Step 5. Remove empty columns. Second line of code. df.drop columns cron, unnamed, 15, unnamed, 16. Explanation for presentation. In this step, we remove columns that do not contain useful data. The variable df represents our dataset. The method drop is used to remove elements from the dataset. It can remove rows or columns depending on how it is used. Here we specify that we want to remove columns. Inside the brackets, we provide the names of the columns that should be removed. The columns called unnamed 15 and unnamed 16 appear because of formatting issues in the original file. These columns do not contain any meaningful information and are mostly empty. Therefore, keeping them would only add noise to the dataset. After removing the columns, the cleaned dataset is stored again in the variable df. This means the dataset is updated and now contains only the useful variables. Step 6. Replace the missing value indicator. Third line of code, df. df.replace 200 snapshot an. Explanation for presentation. In this step, we convert the missing value indicator into a standard missing value representation. Earlier, we discovered that the dataset uses the number -200 to represent missing sensor measurements. However, data analysis tools and machine learning libraries usually expect missing values to be represented using a special value called NaN. NaN stands for not a number, and it is the standard way in Python to represent missing numerical data. The replace method searches through the entire dataset and finds all occurrences of -200. Whenever it finds that value, it replaces it with NaN. After the replacement, the dataset is stored again in the variable df, so the updated dataset is used in the next steps. This step is very important because many statistical calculations automatically ignore NaN values, while the value -200 would incorrectly influence the analysis if it remained in the dataset. Step 7. Convert European decimal format for col in df.columns. Explanation. In this line, we start a loop. A loop means that we repeat the same action many times. Here we are telling Python to go through every column in the dataset one by one. The variable df represents the dataset. The word columns means the list of all variables in the dataset. The variable col temporarily stores the name of each column while the loop runs. So this line means, go through every column in the dataset. If df cordoi dtype chastines object explanation. This line checks the type of data stored in the current column. The expression dfcol means we are selecting the current column from the dataset. The attribute dtype tells us the type of values stored in that column. The word object usually means the column contains text rather than numbers. This condition is important because the decimal problem exists only in text columns. If we try to modify numeric columns unnecessarily, we could damage the data. So this line asks a question: is this column stored as text? If the answer is yes, the next line of code will run. dfcol and as type str.stot replace. Explanation. This line fixes the decimal format in the dataset. In this dataset, numbers are written using the European decimal format. For example, a value might appear as 2,6 instead of 2.6. Computers expect decimal numbers to use a dot instead of a comma. This line performs 3 operations. First, AsType converts the column values to text format so we can safely modify them. Second, replace searches inside each value and looks for commas. Third, it replaces every comma with a dot. For example, a value written as 2,6 becomes 2.6. After the replacement, the corrected values are stored back into the same column. Step 8. Convert numeric columns df, she gant df, apply, pd.to, numeric, errors, ignore. Explanation. After fixing the decimal format, many columns still appear as text. However, we want numerical columns to be stored as numbers so we can perform calculations. This command applies a conversion function to the entire dataset. The function attempts to convert each column into numeric format. If the column contains numbers written as text, it will successfully convert them into real numerical values. Some columns, such as dates or time values, cannot be converted to numbers. The parameter errors ignore tells Python to simply skip those columns instead of producing an error. At the end of this operation, most measurement columns become numerical variables that can be used for statistical analysis. Step 9. Combine date and time into a datetime variable, df, datetime. Maestros PD2, date time df, date, plus df, time, errors, coerce. Explanation. In the dataset, the date and time are stored in two separate columns. However, when working with time series data, it is much easier to combine them into one single variable. This line creates a new column called datetime. The function to datetime converts text values into a real-time variable that Python understands. Inside the function, we combine the date column and the time column into a single string. For example, the date and time values might become something like 10 March 2004 at 18 hours. The parameter errors coerce means that if Python encounters an invalid date format, it will replace it with a missing value rather than stopping the program. df, chufd, df.drop columns. Date, time. Explanation. After creating the new date-time column, the original date and time columns are no longer necessary. Keeping them would only duplicate information in the dataset. This command removes those two columns from the dataset. The cleaned dataset is stored again in the variable df, print df.head, explanation. Finally, we display the first rows of the dataset again. This allows us to verify that the changes were successful. We should now see a new date-time column, corrected decimal values, and properly formatted numeric columns. This final check confirms that the dataset has been successfully cleaned and prepared for further analysis.